Hi everyone. In this video we're going to talk about the diode a little bit, and you need some of this information to do lab 2. So now the lecture materials for week 2 are posted, and this information is also contained within, but let's discuss diodes a little bit. So I'm going to draw the schematic symbol for a diode, and the thing to note is that the diode is a directional device. So it's got an anode and a cathode, and how it behaves in the circuit depends on which way you connect it in the circuit. I'm going to draw a little plus minus here. So the diode has two modes of operation: reverse biased or forward biased. So if I give it a higher voltage to the anode, it's going to be forward biased, and if I give the higher voltage to the cathode, it's going to be reverse biased. So what I want to do is draw a little graph here, and this is something you're doing in the process of lab 2. You're actually plotting part of this graph. So this is going to be VF, the forward voltage across the diode there, and this is going to be IF, the current through the diode. We can also look at the reversed voltage through the diode, which is going to be on the negative side of the voltage scale, and we would get a reversed current through the diode. So the way the diode works is, until if it's forward biased, so you've got the more positive voltage here at the anode, you're not going to get a very high current until it gets above some knee point, which we call which, you know, we could call it V, the barrier potential. Sometimes we call it like the forward voltage in general, but we mean the forward voltage when it's on. So I'll just put a little VB here. And so once the voltage gets above that point, the current actually can increase quite rapidly, and that's when we say that the diode is on. Okay. Now, if the voltage across the diode is reversed and you put the higher voltage over here at the cathode, then you're into the reverse bias region of this graph, and there will be like this tiny little reverse bias current, but really nothing significant. So we say like there's no current flow during the circuit then. But you know, if you allow that voltage to get too big, eventually you will break the diode, and there's a breakdown voltage here. Okay, so regions of the graph here, you know, this side of the graph is the forward, and it's actually this quadrant here. So let me redraw that. This is the forward bias part of the graph, and this is the reverse bias part of the graph. So in lab 2, what you're going to do is you're going to take some basic measure. Well, you're going to watch a video actually of me taking some basic measurements on a diode with the multimeter, just to see if the diode is good. So there's a video link posted for you in Blackboard to watch that for the first half of lab 2. And then in the later half of lab 2, you're actually generating this forward biased curve. And so how you're doing that is you're connecting a little circuit with a DC power supply and the diode connected in a forward biased way, and a resistor like so. Okay, so this is some VS DC voltage. So when VS is very, very small, the diode won't be on. But if you may make VS bigger then the breakdown voltage, then the diode will be on, right? And so what you can do is so what you're going to do is you are going to make Vs bigger than Vb so that the diode is on, but you're going to vary this load resistor, okay? And you're going to measure Vd and Vr through through measurement with your voltmeter, okay? And you're going to calculate the current through the diode, because if you know the voltage across the resistor, that's the same. If you know the voltage across the resistor, you can find the current through the resistor, and that's the same current that's through the diode. So eventually, what you're going to have in your table as you change the resistor is several different values for VD and ID. So you're going to get several different values along this graph, and you're going to see you know, how much this diode voltage changes, and you'll see, you know, you should see that it's actually quite close to this forward bias voltage. And so really what happens in this circuit is as this resistance goes down, the current in the circuit goes up. And if I raise this resistance, then the current goes down. So that's an important consideration when you're using diodes, is that you're going to want to have a resistor here, because without this resistance in the circuit, this current would be too high, and you could actually damage your diode. So so you definitely want to have a resistor. And if we were to flip this diode and turn it around in this circuit, then we would be over here somewhere on the graph, and we would find that we don't actually have any current flow there. So in a sense, the diode is acting like a directional sort of switch, allowing you know, current flow when it's in one direction, but not in the other direction. So take a look at Lab 2, including watching the YouTube video with diode measurements that goes with Lab 2, and then see how you do with taking your data for the Lab 2 circuit, which you're going to build in Multisim now. And you should be familiar with Multisim from having done Lab 1. Okay, if you have any questions, let me know in the live session.